In the windswept deserts of Mongolia, paleontologists recently uncovered something that instantly captured the attention of scientists around the world, a nearly complete velociraptor fossil. But this wasn't just another skeleton. What stunned researchers was the preservation of intricate feather imprints still attached to the fossilized bones. Unlike the scaly, lizard-like predator made famous by movies, this velociraptor looked more like a fierce bird of prey. Tiny quill knobs along the arms confirmed the presence of fully developed feathers, and hints of soft tissue revealed skin textures that challenged everything we thought we knew. It was no longer just a sleek killer, it was a creature far more complex, possibly colorful, and even aerodynamic in design. Even more shocking, the structure of its snout suggested it may not have looked reptilian at all, but something closer to a bird's beak. This single fossil is forcing experts to rethink not just the image of Velociraptor, but its behavior, its role in the ecosystem, and its evolutionary link to modern birds. For decades, our understanding was shaped by Hollywood, not science. But now, the truth is breaking through the stone, and it might be stranger than fiction. For over 30 years, the image of the Velociraptor has been shaped by blockbuster films. The sleek, scaly, man-sized predator from Jurassic Park burned itself into popular culture. But the reality is far different and far more fascinating. Real velociraptors were much smaller, roughly the size of a turkey. They had long, feathered arms, a stiff tail for balance, and likely moved with the grace of a predatory bird rather than a snarling reptile. The fossil uncovered in Mongolia helps confirm that their anatomy was better suited for quick, agile movements, possibly for ambushing prey or climbing. Their feathered limbs weren't wings in the traditional sense, but they provided balance, insulation, and possibly even a role in display or intimidation. Scientists believe velociraptors may have used their feathers to communicate, much like birds do today. This level of social behavior was not something we expected from a cold-blooded killer. But science is proving that the truth is far more nuanced. What we thought was a monster may have been a complex, intelligent predator with behaviors closer to hawks or eagles. The fossil record is rewriting the script, and it's showing us a creature that was more dynamic, more bird-like, and perhaps more terrifying because of it. For years, paleontologists debated whether velociraptors actually had feathers or if these ideas were speculative. But the fossil unearthed in Mongolia included quill knobs, tiny bumps along the forearm bones that serve as anchor points for feathers. These are the same features seen in modern birds, leaving no doubt velociraptors were feathered. This fossil ends the debate. What's more, the preservation was so detailed that researchers could see the direction of the feather shafts, giving insight into how they may have layered and moved with the animal. It's not just about appearances. Feathers suggest complex behavior. They imply thermoregulation, meaning velociraptors may have been warm-blooded, or at least capable of regulating body heat far more effectively than reptiles. This shifts their entire classification. Were they truly reptiles, or something closer to primitive birds? The line blurs quickly, and while feathers have often been associated with flight, in velociraptors, they likely served other functions: insulation, signaling, and perhaps aiding in maneuverability during high-speed chases. The implications are enormous. We're not just changing how they looked, we're transforming how they lived, hunted, and even interacted with others in their pack. All from a few preserved quill knobs embedded in ancient rock. Another revelation from the new fossil lies in its skull and brain cavity. With improved imaging technology, scientists were able to digitally reconstruct the velociraptor's brain case. Comparing it to both reptiles and birds, what they found was surprising. The velociraptor had a relatively large brain for its size, particularly in areas associated with vision, balance, and coordination. This suggests it was not just fast, it was smart, very smart. The enlarged olfactory bulbs indicate an acute sense of smell, possibly used for tracking prey or navigating complex terrain. And the cerebrum, which in birds is associated with problem-solving and memory, was far more developed than expected. This hints at the possibility of learned behavior, social coordination, and even strategic thinking. Could velociraptors have hunted in coordinated packs? Could they have communicated using visual displays or vocal signals? These ideas, once dismissed as science fiction, now have a real scientific basis. For older audiences who grew up thinking of dinosaurs as dumb brutes, this fossil provides a humbling reminder prehistoric life was anything but simple. Intelligence evolved in ways we're only beginning to understand, and Velociraptor may have been one of the smartest predators of its time. Everyone remembers the terrifying sickle-shaped claw on the Velociraptor's foot. Movies show it slashing into prey with brutal efficiency. But recent studies, including evidence from this new fossil, paint a more precise picture. The claw wasn't just a weapon, it was a tool. Researchers now believe velociraptors used their claws to pin down smaller animals, much like modern birds of prey. The structure of the foot shows adaptations for grasping, not simply slashing. Once prey was pinned, the velociraptor could use its jaws and arms to finish the kill. This is eerily similar to how hawks and eagles immobilize their victims today. It's a more methodical, strategic hunting method than previously thought. The fossil also shows wear patterns on the claws that suggest regular use, not just for hunting, but possibly for climbing or manipulating objects. Combined with its keen senses and agility, Velociraptor was a predator that relied on precision rather than brute force. It wasn't a wild monster, it was a tactical hunter. For older generations raised on outdated dinosaur textbooks, this reimagining is profound. Nature doesn't always favor the biggest or strongest, but often the smartest and most adaptable. One of the most thrilling aspects of the new fossil is the potential to uncover the Velociraptor's coloration. Using microscopic analysis, scientists examined preserved melanosomes, tiny structures in feathers that help determine pigment. While full color reconstruction isn't yet possible, early findings suggest that velociraptors weren't dull gray or brown as once thought. Instead, they may have had bold patterned plumage, perhaps stripes, mottled tones, or even iridescent highlights, much like modern crows or pheasants. These colors could serve many purposes: camouflage in complex environments, signaling between individuals, or even courtship displays. It's an unexpected layer of beauty in a creature long considered purely brutal. For an older audience, this challenges yet another assumption that prehistoric creatures were drab and uniform. Instead, Velociraptor may have been visually stunning. These insights also bridge the emotional connection between dinosaurs and birds. We see these same pigments in hummingbirds, pigeons, and even peacocks today. The more we study fossils, the more the boundaries blur between ancient predator and backyard bird. What once seemed like a monstrous reptile might have had a splash of color that caught the sunlight, proof that evolution paints with every color on the palette. Even 75 million years ago, could velociraptors have cared for their young? It's a question that sparked debate for decades. The latest fossil hints at a potential answer. Found near the adult specimen were fragments of eggshells and traces of juvenile bones, suggesting the possibility of nesting behavior. Similar finds in related raptor species show adults positioned protectively over eggs. Similar to brooding birds today, while not conclusive, it adds to the growing belief that some dinosaurs, especially those closely related to birds, exhibited parental care. This breaks from the traditional view of dinosaurs as solitary, instinct-driven machines. If velociraptors raised their young, taught them to hunt, or protected them in nests, it would place them closer to birds than lizards in social behavior. The implications are enormous, for understanding dinosaur evolution. And for viewers over 40, it challenges the black and white view we once had of prehistoric life. Dinosaurs were not just survival machines, they were part of complex ecosystems, with behaviors that included nurturing, learning, and perhaps even mourning. The more we uncover, the more human, ironically, they begin to seem. It's not about making them cuddly. It's about understanding their world on a deeper, more accurate level. Velociraptor wasn't just another predator. It represents a critical link in the evolutionary chain from dinosaurs to birds. With feathers, hollow bones, and bird-like posture, it shared more traits with modern birds than with crocodiles or lizards. This isn't just speculation, it's backed by fossil evidence from multiple raptor species, including the recent Mongolian discovery. As we connect the dots, Velociraptor begins to look less like a prehistoric outlier and more like a missing chapter in avian evolution. Its anatomy bridges two worlds, the age of reptiles and the age of birds. That transition wasn't a sudden leap, it was gradual, with creatures like Velociraptor at the center. For an older audience familiar with the idea of sharp evolutionary divides, this discovery shows how nature often works in subtle gradations. Evolution is messy, experimental, and full of dead ends, but occasionally, it gets something just right. Velociraptor, with its intelligence, feathers, and speed, was one of those evolutionary success stories. And though it went extinct, its legacy lives on every time we hear a bird sing or see one take flight. The new Velociraptor fossil isn't just about correcting a few movie myths. It's a wake-up call for how we think about the past. Paleontology isn't a closed book. It's an ever-evolving story, shaped by every bone, feather, and fossilized trace we find. Discoveries like this remind us that history is far more dynamic than textbooks suggest. They also show how far science has come in recent decades. Technologies like 3D imaging, chemical analysis, and microscopic scanning have turned stone into stories. For viewers over 40, it's a chance to re-engage with the world of dinosaurs, not as monsters from childhood, but as real, living creatures with depth and nuance. It's also a lesson in humility. We once thought we had these animals figured out. We were wrong. And that's the beauty of science. It changes with evidence. Velociraptor is no longer just a movie villain. It's a symbol of how curiosity, patience, and open-mindedness can rewrite history. And in a world that often feels stuck, that's a powerful reminder of what discovery can still do.